The building of knowledge results in new information being held temporarily in our working memory networks. But there it's vulnerable to being lost. It requires conscious effort to maintain it in our conscious attention. And there is always more to be learned, so that limited working memory capacity is soon going to be needed for further incoming information. This is why consolidation through active rehearsal and practice is so important. It helps store our new knowledge in long-term memory. And it can also help us to just know something automatically without having to make a conscious effort to remember it. At the beginning of a study of adults practicing multiplication, researchers found activity was particularly great in a region of the frontal lobes linked to working memory. The learners were, at first, having to consciously follow a process, remembering where they were in the process, avoiding likely errors, monitoring for mistakes as they proceeded. After practice, however, this activity was reduced and replaced by activity further back in the brain, in a region linked to more automatic processing. In general, we might think of consolidation as the processing of information shifting from temporary to long-term memory, from processes involving those frontal working memory networks to those involving a broader set of brain regions across the cortex. Of course, it is worth emphasising that by rehearsal, we're not talking about the teacher repeating information in front of their pupils. This is about learners actively rehearsing and practicing the application of their new knowledge. In another study, researchers looked at Swedish students learning the language of Swahili. For Swahili words that were securely learnt and consolidated, they again noticed reduced activation in those working memory networks. However, these researchers also noticed that brain activity for words that could later be remembered was more variable compared with words that would later be forgotten. Do you think this is odd? Perhaps you might have expected that if someone had consolidated a word very well, you might see a single, well-defined representation of it in the brain. Actually, the variability that the researchers noticed makes perfect sense. Rehearsing your new knowledge in different ways will connect it with your prior knowledge. You might remember that if the pattern of neurons coding for an old and a new idea activate together, then connections between those patterns will form, so that one pattern will automatically activate the other. So now many different older patterns of activity can be included in the neural pattern for what's just been learned. We have multiple representations of that new learning. If many things from your prior knowledge can bring to mind your new knowledge, this can make it easier to find your new knowledge and to apply it. To understand why multiple representations of a piece of knowledge make it more useful, think about what makes a hat useful. Having a hat becomes more useful when you have many different hats in your house, because you're always likely to find a hat, and you're more likely to find one that fits the occasion. There are many ways of consolidating new learning and building these multiple representations of a concept in the brain. Through discussing a concept, through expressing it in different forms as a text, as a diagram, as a presentation, through enacting it through our bodies. Encouraging students to make connections between these different forms of expression of a concept will help build multiple representations of it in their brains. Finally, we need to mention sleep, because although teachers have little control over the amount of sleep that their pupils have, it is so important for consolidation of learning. In fact, some scientists refer to it as the price we pay for plasticity. In other words, sleep is necessary if we want to be able to learn. At night, we usually experience around 4 or 5 cycles of sleep, with deeper stages in the middle of each cycle, during which the brain emits slower, larger waves of electrical energy. This is called slow wave sleep. During the day, our learning generates new patterns of brain activity in our cortex. At night, during slow wave sleep, the hippocampus helps our cortex to replay those patterns. This is important for distributing the memory of our learning more permanently in our cortex. So last night's sleep is not just important for feeling ready, refreshed and rested so that we can learn today. It's also absolutely necessary to make sure that we don't lose what we learnt yesterday. So lost or disrupted sleep can have a doubly negative effect on learning. In this video on the consolidation of learning, we've discovered how the rehearsal of new knowledge helps it become more permanent, accessible and useful, freeing up our limited working memory ready for further learning. And also how applying our knowledge in different ways helps build up multiple representations of it in our brains, and why that is so useful. And we've also discovered the value for learning of a good night's sleep.